Everybody, this is Digital Blackboard by Sachin Pinagmute. In this video, we are going to discuss the topic Laplace transform of periodic function. So we are having one question: find Laplace transform of periodic function shown below. Now, first of all, what is periodic function? So if you observe this function or the waveform given to us, so from 0 to pi, we are having one cycle, okay, and the same cycle is repeating over the period of time. So such waveform or such function is called as periodic function. So periodic function means the cycle getting repeated after some time interval over a period of time. Okay, so the Laplace transform of periodic function is given by f of s is equal to f1 of s into 1 upon 1 minus e to the power ts. So what is f of s? So f of s is nothing but Laplace transform of periodic function. So f of s is Laplace transform of whole periodic function. F1 of s is equal to Laplace transform of first cycle of periodic function. So if we want to find out f1 of s, then we have to concentrate on only the first cycle of periodic function, and t, that is capital T, is time period of first function. So here t is written, so time period of first function. Now we know time period is nothing but time taken to complete one cycle. So here the first cycle is getting finished at pi. So 0 to pi we are getting time period. So time period is nothing but here pi. Okay, so by keeping these things in mind, we are going to obtain its Laplace transformation. So in Laplace transformation, first of all, we will find out f1 of s, that is Laplace of first cycle of periodic function. So we are having the first cycle of periodic function. Now after observing this function carefully, we can easily find out that from 0 to pi we are having the first function, and 0 to pi we are having two variation. So the value or the magnitude of the function is increasing from 0 to 1, okay, but it is increasing linearly. So the first is nothing but ramp. So this function is ramp function or ramp signal. After that the magnitude is decreasing from 1 to 0, but at time pi only. So in one step the input or the function is value of magnitude is decreasing from 1 to 0. So the second function signal is unit step signal. Okay, so the first cycle is combination of ramp and unit step. The first combination is sorry, the first function is combination of ramp and unit step. So we need to write down three equations, because first for one ramp we have to write down two equation. The first equation is original equation, and the second equation is to nullify the effect of ramp. So for one ramp we will write down two equations, and then third equation will be for unit step. So we will first of all obtain three equation in time domain. So for ramp we know we have to consider the slope of ramp. So what is the slope of ramp? It is given by y2 minus y1 is equal to x2 minus x1. So x1 and y1 we get at starting point of that ramp. So we are going to obtain the values of x1 and y1 at starting point. So here x1 is equal to 0 and y1 is equal to 0. And then x2 and y2 can be find out at ending point of that ramp. So x2 and y2 can be find out at this end point. So x2 is equal to what? X2 is equal to pi and y2 is equal to 1. So slope of the ramp become y2 minus y1 upon x2 minus x1 is equal to 1 minus 0 upon pi minus 0 is equal to 1 by pi. So 1 by pi is the slope of this ramp. Now let's start with writing down the equation for f1 of s. For f1 of t, we will obtain f1 of t first. So f1 of t is given by, so first of all ramp. So f1 of t is equal to 1 by pi r of t into u of t minus 1 by pi r of t minus pi into u of t minus pi. So 1 by pi is slope of the ramp, r of t into u of t. So ramp function is denoted by r of t, and with that there is always unit step function associated. And as the ramp is starting from 0, so only r of t into u of t. Then to nullify the effect of this ramp, we have to apply another ramp with negative slope. So hence the original slope is 1 by pi, so opposite slope is minus 1 by pi r of t minus pi, because we are nullifying the effect of ramp at instant pi. So that's why r of t minus pi into u of t minus pi. Okay, so two equations for one ramp. After that the magnitude is decreasing from 1 to 0. So as magnitude is decreasing, so in unit step function we have to consider the magnitude. So minus 1 u of t minus pi, because unit step function is at pi. So u of t minus 1. So we obtain f1 of t here. Now we will take its Laplace transformation. So f1 of s will become, so taking Laplace transformation of f1 of t, so f1 of t Laplace transformation is f1 of s, so it is coming 1 by pi. The Laplace of ramp is always 1 by s square, so 1 by pi into 1 by s square minus again 1 by pi for ramp 1 by s square, but as it is delayed or shifted t minus pi, so e to the power minus pi s. Okay, then for unit step function, the Laplace transformation is 1 upon s, and as it is delayed, so e to the power minus pi s. So we obtain here the f1 of s, that is Laplace transform of first function of the periodic waveform. Now in this we can take 1 by s common. So after taking 1 by s common, the equation become 1 by s in the bracket 1 by pi s minus 1 by pi s e to the power minus pi s minus e to the power minus pi s. Okay. So we now how to obtain f of s. So f of s is nothing but f1 of s into 1 upon 1 minus e to the power minus ts. So what is t? The t already we know, time period. So it is come to be pi. So here we will write 1 upon 1 minus e to the power minus pi s. So we got the Laplace transform of the periodic function given to us. So I hope you understood this problem clearly. Okay, so please like, share and subscribe the channel Digital Blackboard, and for any query you can contact sachin@gmail.com. Thank you very much.